Hello everybody, welcome to Pencil College. So in the previous video I have gave you an introduction to kinematics. So now in this video we're really gonna start things proper and work out the mathematics of kinematics. So what do we have to learn today? We need to learn how to find displacement, velocity, acceleration at any instance. And we have to find the actual distance traveled from the direction of motion of its velocity. Before that, I want to read you a few definitions about distances, displacement, speed, velocity, and acceleration. Okay, so we learn distance and displacement. We always think that it's the same, but it's actually not the same. Okay, distance is is a length you actually travel. Okay, um, it is a scalar quantity, meaning that you only look at the number, there's no direction. Okay, so for example, let's say if you move from here to here, then you move back, the total distance would be this path in black in color. Okay, that's the total distance. However, displacement is it is the length between you and a fixed reference point. So for example, if this reference point is here now, the displacement, I shall show the path, the same path, to go this way and go there and back. The displacement is actually 0 because you are 0 distance away from the reference point. So that's the difference between displacement and distance. Okay? Speed now is the rate of change of distance with respect to time, whereas velocity is the rate of change of displacement of this particle with respect to its displacement. Okay? Well, an acceleration would be the rate of change of this velocity. Okay, so some definitions that you have to take note. Right? Now in the last video, I have showed you that you can write v, so the velocity can be expressed as the rate of change of displacement with respect to time, and the acceleration can be expressed as the rate of change of velocity with respect to time. Now v is ds dt, so I can rewrite this as d dt of ds dt. Okay, now this gives me d2s dt square. Okay, so I can also write it in this form. It's an equivalent form. Okay, so if I were to have to integrate to find v, then I can actually also integrate a dt. This gives me v. Okay, actually with another constant if this is not a definite integral. Okay, and also if I were to integrate v dt, I would also get s plus another constant. Okay, I've shown you this in the introductory video, so a little bit idea of how this works. So we'll try an example to confirm some stuff. Okay, a ball travels with displacement time graph of s equals to 10t minus 5t squared. So determine the time when the ball is instantaneously at rest, and hence you can determine the maximum height reached by the ball. Okay, so this applies certain concepts that we have learned before. So I'll piece the puzzle for you in this example. Okay, now we have to find when the ball is instantaneously at rest, which this also means that the velocity has to be 0 at that point. Okay, because instantaneously at rest just means that, at rest just means you have no velocity. Well, okay, but ds dt gives me the velocity. So what I have to do over here is I just have to say that ds dt equals to v, and I differentiate this equation to give me 10 minus 10t. Okay, now I have to find it where velocity equals to 0. then I just bring this over, and this happens when 10 equals to 10t and t equals to 1. So the particle is instantaneously at rest when time is equals to 1. Okay, so I have answered the question. So determine the time. So the time is where time is equals to 1. The particle is instantaneously at rest. Okay? Okay, the next part of the question say hence, determine the maximum height reached by the ball. So, to find the maximum height reached by the ball, actually I look at height. Height is a displacement quantity related to s. Okay, and therefore in order to find the maximum height, it's like finding the stationary point. However, we have already found the stationary point over here. This means that by finding the stationary point of the ball, you are actually finding the point where the velocity equals to 0. This actually gives you a stationary point, whether be it a maximum height or a minimum height. We can test it out. Okay, we can test it out. So, when t equals to 1, let's sub this back into s. So s when t equals to 1 will give me 10 times 1 minus 5 times 1 squared, which is 5. Okay, so the displacement away is actually 5. Now we have to check if this is a maximum or a minimum height. Okay, because the displacement away from the origin is 5. But we don't know whether this 5 is a minimum or a maximum. Okay, so this is 5. This is where the ball is at its stationary point. So where it's instantaneously at rest. Right, so we have to check. So how do we check? We do a first order test. We can do a first order derivative test as well. So we check whether ds dt at 1 is equals to 0. At 1 minus, at a little bit lesser than 1, what we actually get is the gradient over here is positive and negative at 1 plus. Okay, you can check this by putting it in here. Just a number a little bit smaller than 1 over here, and you get a positive number. Number a little bit bigger than t over here, you get a negative number. Okay, so this says that it is a maximum point. Okay, so we have answered the question that 5 as equals to 5 is a maximum point. And this is the maximum point of the ball at its peak of its trajectory. So we can think of it as a ball being tossed upwards, and then after that coming down. Okay, and then at this point is instantaneously at rest. Okay, and this distance here is s is equals to 5. Let's try another example. A car's velocity is given by the equation v is t squared minus 5t plus 6. So find the initial acceleration at the time where the car is traveling at a constant velocity, and determine if this velocity is a maximum or minimum velocity. And lastly, you have to determine the displacement and distance traveled by the car from the origin t equals to 0 till that instant. Alright? So let's first find the initial acceleration. Okay, so the initial acceleration a is equals to dv dt. Alright, and dv dt is just 2t minus 5. So the initial acceleration is when the time is equals to 0. Okay, so we start where the time equals to 0, we will get negative 5. So this is the initial acceleration. Acceleration. Alright, the next thing we have to find is where the car is traveling at a constant velocity. So when the car is traveling at a constant velocity, the acceleration equals to 0. Okay, so minus 5 equals to 0. And this is the time where t is equals to 2.5. Okay, so this is the time where the car is traveling at constant velocity. Okay, because at constant velocity you do not accelerate, you do not decelerate. So therefore acceleration equals to 0. And this is our acceleration relationship. Okay? Now determine if this velocity is maximum or the minimum velocity. So we are trying to say that at this time t, at a constant velocity, is this a minimum or a maximum? So what we have to do is we have to do a derivative test. So we can either do the first derivative or second derivative test. Just now we had did the first derivative test, so now let's do a second derivative test. So all I have to do is to do d2v dt square. So basically I just d dt of a, right? And all I get is 2. So 2 is more than 0, and hence it is a minimum point. So this is the lowest velocity the car ever went to. Okay? Last but not least, I have to determine the displacement and distance traveled by the car from the origin and t equals to 0 till that instant where it is at the maximum velocity. So I want to find from t equals to 0 to t equals to 2.5. How much have the car traveled? So in this case, to find distance, we have to integrate v dt. So I said it in the previous slide. However, we want to do it only from time equals to 0 to time equals to 2.5. Now you know that if I have a vt graph, the area under the graph would be the displacement, right? If this is v and this is t. Okay, and so this is what we are doing from 0 to 2.5. What is the displacement traveled? Okay, so integrate v dt, and what I get is actually integrating this graph from 0 to 2.5. So I integrate t squared minus 5t plus 6. I integrate it from 0 to 2.5 dt. Okay, so what I get is t cubed over 3 minus 5 over 2 t squared plus 6t. So I have to do it from 0 to 2.5. However, doing so may not be correct, because we have to check that this 2.5 is actually larger than 2. So we cannot actually just do this properly, just do this in this way. We have to do it properly. So let me just pull down the page a little. And by right, what I have to do is, let me just copy this thing. T cubed over 3 minus 5t squared over 2 plus 6t, 0 to 2.5. So I cannot just sub in 0 to 2.5 over here because it will be wrong. What I have to do is I have to take note that 2 is a minimum point, and so therefore from then onwards the signs will actually change. Okay, so I have to do it from 0 to 2, and then add in doing it from the same expression from 2 to 2.5. However, in this case, I have to take the absolute value of this thing. Plus 6t. Right? So this case is very straightforward. Just putting in 2, I get 8 over here. minus 20 over 2 will be 10, and 6t will be plus 12, plus t cubed over 3, and t cubed over 3 here will be 8, so it'll be 8 over 3 minus 40 over 2 plus 12, and I'll bracket this up, and I have to take away the case where it is 2.5 minus 5 times 2.5 square over 2 plus 6 times 2.5. If I work this out, this will give me an answer 19 over 4.